record. I turned on so many things. I forgot to turn on the recording. So I think I've got everything turned on now. Recording, live captions, and shared screen. 9.2 is where we were. And I'm just going to look through and see what it talks about in 9.2. There we go. Function value, quadrangles, conditions. Okay, Pythagorean identities. All right, well, let me go ahead and get that to you. And I'll go ahead and look that up right now so I can get it to you. Let's go with Trig Identities. Trig Identity sheet. I usually use this green one. That's the one I usually use. So I'm going to send it to you. And I'm just going to send the copy, and then you can put it on whatever you want to. Save image as Trig Identities. That's under downloads. I've already got it saved, so I'll go ahead and send that to y'all right now. And we are going to start on them today, but we're not going to start working them. We're still working with trig functions right now. So I'm going to send this, upload, downloads, trig identities. This is just the picture. I want you to save it and put it on a word processor and fix it however you want to. Somebody give me a thumbs up when you see it. Okay, so make sure you use that accordingly. That's the one that's got everything on it. I'm not gonna spend any. I don't know why it's got a play on it. It's not a video. I don't know why it did that. But anyway, go ahead, and before we do the next class, you need to have this on a piece of paper so you can use during class, homework, and test. Okay, so make sure you write that down, or make sure you print that out. All right, with that being said, let's move on to some problems, and let's do some homework problems, because the best way to do identities, or the best way to do trig functions, is to actually do the problems. So I'm going to go to your assignments, and we're going to hit 9.2. And there's only 4. Really? That's not valid. I might give you another 9.2 homework. Oh my gosh. Oh no, we're gonna do some more. Let me go to the study plan. I don't know why there's only 4 questions on that. Sorry about that. I'll have to add some more, make another homework. 9.2 and study plan. That's more like it. We'll have to find out what's going on with that 9.2 homework. Let me find a good problem or a good test question to bring home the trig functions. So far, these are really crappy questions. All right, let's go with this one. The heck with it. All right, I'm tired of looking. This one says, and I can't blow it up. I don't know why I can't blow it up. It says sketch the angle, blah, 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 and give the 6 trigonometric functions of -5 and 12. So -5 and 12. -5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there is our -5 and 12. So -5 is our adjacent because our little man is right here. So that's equal to adjacent. Therefore, this is equal to opposite. Opposite is equal to 12.
You have a work email.
Use our Pythagorean Theorem. A squared plus B squared is equal to C squared. We do not know C squared, so we are going to solve for C squared, or C. So C is equal to -5 quantity squared plus 12 quantity squared. And that's going to be the square root of 25 plus 144. And the square root of 169 is what? 13. So C is equal to 13. Now we're ready to do our 6 trigonometric functions: sine, cosine, tangent. Oscar had a hunk of apple. Oscar, 12, had, which is H, sorry. Oscar had be 12 over 13. A hunk, which would be -5 over 13. And of apple, 12 over -5. And then flip it for your cotan. -5 over 12. For your secant, -13 over 5. And for your cosecant, 13 over 12. That is a test question. How many will you have on the test? Probably 5,000, because I'm going to put, this is where you're doing the foundation for your trig. So you're going to get a lot of these on the test. Who's got a question? All right. Only thing I'd like to show you at this point is another property of trig. All students take calculus. Anybody from pre-calculus days know what this means? Yes, no, maybe?
I don't remember seeing that.
You are kidding me. In the first quadrant, all, and I'll put in different colors because all students, that's the, I don't know what you call it, idiom, algorithm, I don't know what you call it. But anyway, you English people, you know what it's called when something stands for something. I thought it was an idiom, but it might be something else. All trig functions are positive in the first quadrant. Students, sine, and what's the reciprocal of sine? cosecant are positive in second quadrant. See, the S stands for the sine and the reciprocal of the sine. All means all trig functions are. So what would what would take be? What trigonometric function you think is going to be positive in the third quadrant?
Tangent.
Tangent. And what's this reciprocal?
Cotangent.
And what do you think is positive in the fourth quadrant? Cosine and what? All students take calculus. Why? Why is this so? Because x in this direction is positive, and y in this direction is what? Positive.
Positive.
So everything in the first quadrant is going to be what? Positive. Here, what is x? So there's going to be a couple in here that are what? Positive divided by negative or negative divided by positive, which is what? Negative. So that's why you got some that are positive and the others are what? Negative. Now, you can either do it this way. You can either do the numbers and just say, okay, well, that's cotangent. Cotangent is going to be negative, so negative blah, blah, blah. You can do it that way. Or you can do the signs with the negative on the x and the positive on the y and do it that way. I don't care which way you do it, as long as you do it correctly. Everybody with me? So what is x in the third quadrant? Negative. What is y? Negative. So that's why you get these to be positive and the rest negative. And x is positive and y is negative. So these. And that's why, if you remember, all students take calculus. You won't have to worry too much about the signs, and you just write down cotangent. And if the cotangent is in the second quadrant, you know it's negative. If you do the cotangent in the first quadrant, you know it's positive. Everybody with me? Hopefully you write this down. You'll understand it as we go along and do more problems. This is just all students take calculus. This is a quadrant rule. Quadrant rule. All students take calculus.
You have a work email.
Oh Lord, somebody's bitching about something. Somebody said it, I said something. I must have offended somebody today. All right, let's do another question. I lost my question. I don't even know which one I did. So let's just pick one and find one that I would put on a test. Y'all should already know how to rationalize. All right, we just did that one. All right, there's two negatives. -3, I'm going to let you do this one. I'm not going to draw it for you. I'm going to let you do it. -3 and -4. Go to it. Do everything. -3 and -4. Go to it. If you can't do it, then we'll just mark it up as being a complete disappointment and failure. Mr. Shirley, is that a Georgia Bulldog hat you got on?
Never will be.
No, that was just getting struck.
Oh.
Win or lose, I got to stick with them.
This didn't have any questions.
Well, as long as you don't name your firstborn Clemson and sacrifice live animals before a game, you're all right.
Oh,
Yeah, I won't do that.
Well, there are some that are crazy. I do know of a couple that named their son Clemson.
That's too much for me.
Also know a couple that painted their house and the inside of their house orange.
So,
See,
And they
orange
do
is my
not live in
favorite color,
South
but I
Carolina.
can't do
Huh?
that. The orange is my favorite color, but that'd be too much.
I cannot stand orange, and especially with black. I can't stand Halloween colors. So what quadrant are we in? We're in the third quadrant. All students take. So we know the tangent and the cotangent are positive. So I can go down here and I can write sine, cosine, tangent, cotangent, secant, and cosecant. And I can already say this is going to be negative, that's going to be negative, that's going to be positive, that's going to be positive, that's going to be negative, and that's going to be negative. Is that important? Yeah, that's important. So you can check your answers and make sure you don't have a wrong answer. All students take calculus. And y'all have never seen that in pre-calculus before.
No.
Must be some of that new math they're teaching y'all.
I saw it. I just forgot what it meant.
Oh, you have seen it. Good. Then you know I'm not crazy. I'm not making it up. That's the main thing. I want y'all to make sure that I'm not crazy. I didn't just make that up. All right, so we've got a -3 here and a -3 here. So -3 squared plus -4 squared is equal to C. We'll take the square root of that. So that's going to be 9 plus 16. And 25 is 5. So this is your little man. So he's got his foot on the hypotenuse and the adjacent. And the opposite from him is the opposite. O is equal to, what is that, 4, -4? Oscar had a hunk of apple. Oscar, -4 over 5. -3 over 5. And -4 over -3, which is positive what? 4/3, 3/4, -5/3, and -5/4. Now, what is hard about that? That's not hard at all. But you'd be surprised on how many students could be lobotomized just over going over this. Another test question. Make sure you can do it. Let's go find another one. I want to find one where the hypotenuse is not given. But I don't know if they're in this homework or not. Where the hypotenuse is given. And let's see what this one says. These are quadrangles. Let me go ahead and tell you about the quadrangles. That's another property of calculus. On your unit circle, technically, you go in X direction 1 and 0. So this one is 1, 0. This one, you go in the x direction 0, and you go in the y direction 1. This one, you go in the x direction -1 and the y direction 0. And then here, you go in the x direction 0 and the y direction -1. This is 0 degrees and 360 degrees. It's also 0 degrees and 2 pi radians. Okay? And of course, this is 90 degrees or pi over 2. This is 180 degrees or pi. And this is 270 degrees or 3 pi over 2. Now, what I've just given you is the cosine and the sine. So I want you to make a note of that right now. I'm going to highlight the cosine in orange. That's the cosine. And you'll see this later. I'm going ahead and showing you right now. And the green
Work email.
is the sine. So if I asked you, what is the sine of 360 degrees or 2 pi? You would say 0. What is the sine of pi over 2? 1. What is the sine of 180 or pi? 0. What is the cosine of 3 pi over 2? -1. What is the cosine of 0? 1. What is the cosine of 90 degrees? 0. What is the cosine of 180? -1. What is the cosine of 270? 0. Okay? These are what you call your quartic functions. They're right on the what? They're right on the border between the quartiles. That's why they're called quartic. I don't know what they call them in the book, but they're called quartics, I think. Quartics, or let's see, what do they call it here? Terminal side, you could say that. All right, so let me move on, find another test question. If you're wondering, some of these that I'm skipping, I would not put on the test. These are quartics. This is what these are. These are quartics. I don't put a lot of those on the test. They put a lot of junk in here. I can see why they. Okay, here we go. Okay, 3 comma. I think that's a comma, isn't it? Is that a comma? That's a very faint comma. -3 and the square root of 2. Go ahead and start on that one. -3 and the square root of 2. -3 comma square root of 2. All right, I'm going to let y'all work on that one for about 2 minutes, 2 or 3 minutes. Go ahead. Got an X and a Y. Of course, there's a radical there, so some of y'all will automatically shut down before you work the problem because it's got a radical in there. All right, so we've got all students take calculus. We've got, sorry, -3 and positive 1.4. So there's a little man. And the adjacent is -3. The opposite is the square root of 2. So adjacent is equal to that. Opposite is equal to that. And we use the Pythagorean Theorem. So -3 squared plus the square root of 2 squared is equal to C. And that's going to be 9 plus 2 is equal to C. And the square root of 11 is equal to C. So H is equal to the square root of 11. Now we already know that the sine and the cosine, the sine and the cosecant are going to be positive. So I'm going to break from tradition here because I usually do mine vertically, but I'm going to do it horizontally. Sine, cosecant, cosine, secant, tangent, cotangent. So I know this one's going to be positive, and this one's going to be positive, and these are going to be negative. That's kind of a nice thing to have going into a problem, at least knowing what's going to be positive and negative, so you can check your work and make sure you don't have something wrong. Capiche? Y'all just not the talkative group, are you? I can imagine y'all at the dinner table. I'm sure y'all just all sit there and just look at each other. Is that what y'all do? Don't talk? No, let me guess. You text on your phones while you're eating. That's what you do?
No, I watch TV.
You watch TV? I do too. I despise to. When I eat, I have to. Yeah, I agree, 100%. My mama used to get mad at me about that, but I couldn't. We did the Ozzie and Harriet, sitting at the dinner table. We did that till about I was in 6th or 7th grade, and then afterwards, even my dad was like, "Let's go in the den and watch TV." So here we go. Oscar had a lump of apple. Oscar had the square root of 2 over square root of 11. And adjacent -3 over square root of 11. And square root of 2 over -3. Now I'm going to flip everything over. And that's going to be square root of 11 over 3. And square root of 11 over 2. Now, of course, we've got a couple of things that just don't work. And that's those radicals. We got a radical here that needs to be addressed. A radical here that needs to be addressed. A radical here that needs to be addressed. And a radical there that needs to be addressed. So we've got to rationalize. So I'm going to multiply by the square root of 11 over the square root of 11 here. And the square root of 11 over the square root of 11. And the square root of 2 over the square root of 2. And the square root of 2 over the square root of 2. And our final answers are, I'm going to write them in black, I guess. 2 square root of 11 over 11. Negative 3 square root of 11 over 11. Negative square root of 2 over 3. Negative 3 square root of 2 over 2. Negative square root of 11 over 3. And the square root of 22 over 2. Now you no, you can't fool with that. That's your answers. And look, positive, positive. Kind of a way to check yourself. Now I can tell you that's a test question. Why would you say I'd put that on a test? Because y'all would see that, and some of you would skip it because of that. So you can bet your bottom dollar this is going to be on the test. All right, let's try one more before we move on. So that way you really have the concept of the trig identities, because it's important. I was wanting to find one that doesn't have, well, there's one with 2. Let's do that one. Square root of 7, square root of 2. All right, go to it. Okay. All students take calculus. And this is positive, positive. So the square root of 7 is like 2.57. 1, 2, 3. And the square root of 2 is 1.4. So there is our, and that's going to be square root of 7, square root of 2. Little man is right here. Now that's our opposite. This is our adjacent. And that's our hypotenuse. I guarantee you ain't never had this explained to you like I explained it. With the little man, I guarantee you nobody ever told you about the little man.
That's how my high school teacher did it.
The little man?
Yes, sir.
Oh, no.
Yeah, we're the only
Where'd
2
you go to
people.
school?
Anderson Christian School.
I'm willing to bet you. How old was your teacher?
40s.
No, it couldn't have been one of my students. Wow. That's a concept I came up with as this my little thing. That's wild. I did have one of my students become a teacher and start teaching, and I guessed one of my students at Tri-County. I said, "Who is your teacher?" Or I said, "How old is your teacher?" And they said, "Oh, he just graduated." I said, "What's his last name?" And it was one of my students. They're using my stuff in one of their. And that's fine. But I really didn't know that other teachers used the little man. Usually they just call it theta and they don't even tell you. They just say theta.
Y'all are the only two people I know that do it.
What?
Y'all are the only two people I know that do it that way.
Well, I'm going to be honest with you. I didn't think anybody else did the little man. Oh, well. I learn something new every day. I'll tell you a little story. Y'all know the handouts that I send y'all? I've been doing that for years. And come to find out, the one of my department heads sent out a thing of her emails, and it had she had some handouts. And guess where she got the handouts? She stole my handouts and she modified them. I said, "Where'd you get those handouts?" She said, "I got them from you." Because I have to send her what I send students. She took my handouts. She stole my handouts. That's plagiarism. All right. So the square root of 7 squared plus the square root of 2 squared equals C if we take the square root. And that's going to be 7 plus 2 equals C. And the square root of 9 is C. So 3 is our hypotenuse. Sine, cosine, tangent, cotangent, secant, cosecant. And we know that all of them are going to be positive. Oscar had square root of 2 over 3. A hunk. A is square root of 7 over 3. Of apple. Square root of 2 over square root of 7. Multiply by the square root of 7 over the square root of 7. Square root of 14 over 7. And then just flip them over. It's going to be 7 over the square root of 2. Multiply by the square root of 2 over the square root of 2, which is equal to 7 square root of 2 over 2. Secant, 3 over the square root of 7. I'm not rationalizing, I'm running out of room. And 3 over the square root of 2. Which this will be 3 square root of 7 over 7. 3 square root of 7 over 7. And this will be 3 square root of 2 over 2. Which brings us back to this, and that's how you do the sine through the cosecant. Now, let's go back to those special angles. Y'all remember me telling y'all that there was special angles? Remember I told you there was the 30, the 45, and the 60. Y'all remember that?
Yeah, I remember that.
Okay, now we're going to talk about those as far as the sine, cosine, and tangent. So these are called the special angles of trig. You've got your 30-degree angle. You've got your 45-degree angle. And you've got your 60-degree angle. Sine, cosine. I'm just going to do sine, cosine, and tangent. I'm not going to do all 6 of them. Y'all can do the reciprocals if you want to. Now, the easiest one to remember is the 45. 1, 1, square root of 2. That's the easiest one to remember. And the other 2 is easy to remember because 1 is the short side. Square root of 2 is the second to the longest side. Then that would make this 3. And then the 60 and the 30 are related to each other because all you got to do is stand this up on its side, and you got 1, square root of 2, and 3. Are these important? You will fail this class if you don't learn these special angles. Now, I didn't say memorize them. I said learn them. I just told you all you got to memorize is the 45-degree angle. Because once you get there, you know this one short is 1, square root of 2, and 3. 1, 2, 3. And this one is this one flipped on its side. So it's 1, square root of 2, and 3. You always know that the hypotenuse is the longest side. Square root of 2 is 1.7. So you know 3 has to go to the hypotenuse. Because 2, square root of 2 is 1.41. And 1.41. So you know that 3 is the hypotenuse. Now you just put your little man right here. And I want y'all to fill out this chart for the special angles. Go ahead and do that. Fill out this chart and give me the fraction, simplified fraction, for the sine of 30 degrees, the sine of 45 degrees, and the sine of 60 degrees. And you need to simplify it. That means rationalize. Go ahead and fill this chart out. It means you got to do 9 things. So get to it. Miss Reynolds, you're not sick, are you?
No, do I look sick?
No, because every time you're in class, you're in the bed. That's why I thought you might be sick.
Oh no, I had a hip replacement.
Ah, okay, so that's why you're in the bed. I knew you had to be something.
Yeah.
How in the world did you have to have a hip replacement, young as you are? You have an accident or something?
Yeah, I slept in water.
Oh my. Wow. That's awful. You didn't get drunk and fall off the front porch, did you?
No, I was at school.
Oh. Oh my gosh. Oh my. Don't tell me the water was on the floor of the school.
It was.
Oh. I bet they took care of you, didn't they?
Yeah.
I bet they still taking care of you.
Yeah.
I'm gonna be quiet. We're gonna have Reynolds High School. Whereabouts you live, Miss Reynolds?
I'm from Chapin.
In Chapin, there's gonna be a daggum Reynolds High School. Reynolds Junior High and Reynolds Elementary. All right. So Oscar had a hunk of apple. Oscar 1/3. Wait a minute, something's wrong. I'm sorry, I got it backwards. Square root of 3 and 2. Square root of 3 and 2. There we go. My bad. I had to fix that because I knew it wasn't 1/3. All right, so my bad. 1/2. And what is the cosine of that's adjacent? That's square root of 3/2. And this one is Oscar, that's 1 over the adjacent, 1 over the square root of 3, which is the square root of 3/3. Sine of the 45 is Oscar had 1 over the square root of 2, which is square root of 2. Over 2, isn't it? Let's see. I'm doing everything in my head. That'd be 1 square root of 2 over 2. The cosine is 1 over square root of 2, which is square root of 2 over 2. And the tangent is 1 over 1. The sine, Oscar had, square root of 3/2. Cosine, a hunk, 1/2. And then square root of 3/1. And you've just done the angles for the trig functions for the special angles. Make sure you know how to do these. And I will pull those up for you also. Let me go, it'll just be easier. I'm not going to try to find it in the book because it'll just take me longer to find it in the book. So, special angles. And they should have them. Here they are right there. And there they are. 1/2 square root of 2/2, square root of 3/2, square root of 3/2, square root of 2/2, 1/2. Square root of 3/3, 1, and square root of 3. Now I did that whole chart and I didn't memorize a dang thing. How many of you have been through pre-calculus and they told you to memorize? That's the worst thing to do. The best thing to do is remember the 3. Now, you might have to memorize these 3 triangles, but it's a whole lot easier to remember 3 triangles than it is to remember 9 items. See what I'm saying? I would much rather remember 3 triangles rather than 9 items. Now, eventually, after you do it enough times, you're gonna remember them. That is the special angles. So, what can we do with these now? Well, watch. I'm going to show you a trick I learned in the war. Remember me showing you that? And I told you that this was 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360, 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians. I told you that the cosine and the sine, this is going to be 0 and, I'm sorry, 1 and 0. That's your cosine and your sine. This cosine up here is going to be 0, 1. This cosine is going to be -1, 0. And this cosine is going to be 0, -1. And then I told you the special angles are right here. And you can do, okay, that's going to be 45. That's going to be, 30, 45, and 60. And I told you how to change that to radians. And now you can do your what? The cosine and your sine. What is the cosine of 30 degrees? Square root 3 over 2. What is the sine? And now you can fill out the rest of it, because the rest of them just going to be sines. This 30 over here, y'all watch this. Watch now. Negative x, the negative square root 3 over 2, and positive 1/2. You don't have to memorize it. You just have to learn. Let's do 45. What is the cosine of 45 degrees? Square root 2 over 2. What is the sine of 45 degrees? Square root 2 over 2. This negative over here, that x is going to be negative, so that's negative square root 2 over 2. Positive square root 2 over 2. 60 degrees. What is the cosine of 60 degrees? 1/2. What is the sine of 60 degrees? Square root 3 over 2. Over here, negative 1/2. Square root 3 over 2. I did not memorize the unit circle. All I did was take what I know and I fill it out. Isn't it amazing how you don't have to memorize this stuff? Now, will you eventually get faster with it? Yes. But I would much rather learn it than memorize it, wouldn't you? Maybe.
Yeah, that's
Let's
a
go
whole
down
lot
here.
easier.
Say again?
Yeah, that's a whole lot easier.
Let's go down here. What's 45 plus 80? 225? This is going to be negative square root of 2 over 2. Negative square root of 2 over 2. Some of y'all are going, I can't believe that. It's not that difficult. I don't know if y'all look at 225. What is the cosine and the sine? Same thing I got. And I didn't memorize it because I pulled it out of the air. I pulled 225 out of the air. I didn't sit there and go, okay, this is this, this is this, this is this, this is this, this is this. I just pulled 225 out of the air and gave you the exact opposite of those two right there. So let's do another one. What is 360 minus 30? 330 So it's going to be positive square root of 3 over 2 and negative 1/2. So let's look at our handy dandy unit circle. What is 3? Oops, I messed up. I'm sorry. I suck. How did I go back? Go away. 330. What is it? Positive square root of 3 over 2 and negative 1/2. It's amazing. And now that you've got the special angles, now you can do this. You can do your cosine and sine, and now you can do, well, 30, that'll be 30 degrees over 1 times pi over 180. Let's see, 30 will go in there 6 times. That's pi over 6. Now you can go through and put your radians, and you've done your unit circle. Isn't that great? 45 over 1 multiplied by pi over 180. And what will go in there? Let's see, 5 will go in there 9 times. 5 will go in here what? 5 will go in there 3 times and 6, and then 1, and then pi over 4. And then you also look at, there's pi over 4 right there. Oh my, 5 pi over 4. 3 pi over 4. 3 and 5 is what? Odd. So pi over 4, 3 pi over 4, 5 pi over 4. I bet you this one is 7 pi over 4. You see the pattern? Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. You can start seeing the patterns you can fill out without even memorizing. Question, gripe, complaint. All right. You have enough information to go on to 9.2 now. And I want you to work on 9.1 and 9.2. Let's look at the homework and see if I have it. Now that 9.2, I'm going to redo 9.2 homework. I'm just going to revise it because I know some of you have probably already worked on it. So I'm going to give you a revision of 9.2 homework. I'll do that this afternoon sometime, and I'll put it on there for y'all to work it because 4 questions on 9.2, I don't know what happened there, but I'm going to fix it. Everybody with me? You got to have more than 4 questions.
Check 9.3, because I think I did a couple off of 9.3 that were similar to what we've done today.
Okay, so okay. How many questions were on 9.3?
I only did 2 or 3 of them, just because we were, I was only doing 9.2.
Okay,
But there was at least 2 or 3 of them that were what we've done in class today.
okay, so y'all can work on 9.3 also. Hold on, let me get there.
There's 33 questions in 9.3.
Well, I don't know what happened in 9.2. Let me look at 9.3 just to make sure. I'm not saying you're not. I just want to. Looks like 9.3 got short. 9.2 should have more than 4 questions. That makes no sense. All right, I'm gonna give y'all another 9.2. That's unacceptable, but I'll have to do it this afternoon. Okay. Any questions? Did Miss never came in, and I know Miss Martinez didn't come in. Nope, she didn't. Croxton didn't come in. All right, y'all good to go. Work on 9.1 through 9.3. Look for another 9.2. It'll be called 9.2 addition or revised or something. and look for you. And I will see y'all Tuesday. Have a good weekend.
All right, you
Should
do
we-
the same.
Be good. See
Should we
ya.
do the first 9.2